The last chapter covered visualization of information using charts. In this chapter, I'm going to discuss how to appropriately manage, store, and manipulate data within Excel using a variety of tools. The most commonly known data management tool in Excel is the pivot table. However, we're going to build up to that point by looking at some more simple data handling practices, the data table object, and the Excel data model before diving into a fully formed pivot table that utilizes all of those components. At the heart of data management is the concept that if you capture data once, you do not need to capture it or store it again. You should simply reference it for those multiple times. This reduces space, limits the potential for error, and increases the overall value of your data. Most of the examples we've used so far in this course have relied on this concept to work appropriately. The match function, for example, relies on there being a single result that you're looking for, not two or more results. Furthermore, each of our chart series, excepting for the scatter plot, looks at a single data series and assumes that each point is unique from the others. In our invoicing example from the lookup and name chapters, I had a simple relational system across a set of fields where a clear definition existed for each unique field. Ideally, you'll be constructing your data management tools yourself. However, deconstructing data into components can prove invaluable not only to you, but to whomever is lucky enough to follow you. To start this, let's quickly review the invoicing example and talk about how the data is organized. There are 5 tables. There's a client list, a referral details, a line items, and a products. Each one represents a different unique data set. The clients table contains a list of all my clients and nothing else. It stores details that are unique to each client. The referrals lists contains the contact that referred somebody and the contact that was referred. This table simply ties the client list to itself through a mapping table effect. For example, refer 0031 generated 9 new contacts. I can theoretically link the client details for 0031 to the client details for each of the referrals. Additionally, this contains the information as to what type of referral was used. The referral details connect strictly to the referrals data through that code. In this way, I can connect my client list to the referrals detail for both my referral and my referrer. This table of 3 rows can get used over 40 times now without having each of these fields duplicated over and over again. The products table has a similar relationship to line items. The products table provides some descriptive information about each product, such as the various costs, the name, maybe the manufacturer, and other specific details. On the other hand, the line item matches the client to the product and then adds some additional information specific to an entry in an invoice, such as the quoted price and the quantity sold. This data is called a normalized data set, which means that I've already segregated the unique concepts into their own tables. However, it isn't quite database ready yet. I'm going to make those adjustments outside and make the file available to you to download and review, since it's actually quite simple. Rather than walking you through the process with this larger data set that's already been normalized, let's start the process from scratch with a small, raw, flat file data dump. Flat file data dumps are fairly common. They define data in the way that most people actually use the data, with all of the applicable information included within each entry. I've generated this small data dump file from a simple subset of relationships. There is a one-to-one relationship, 2 one-to-many relationships, and a derived many-to-many relationship. These are key terms that will be important in understanding how data management happens in Excel, as we'll be referring to them in our data model component. So let's try to identify and describe what each of them means. A one-to-one relationship means that there is one data set, let's call it the left data set, and another data set, the right data set, where there is a single entry on the left that corresponds to a single entry on the right. These relationships are usually very easy to find and identify. In our case, the one-to-one relationship is between the store name and the store account. Each store has a single account, therefore there is a one-to-one relationship. Now let's think about how VLOOKUP works. VLOOKUP searches for a one-to-one match. So we could take the store name and the store account, bring them to the side, and go to our data, remove duplicates. Removing the duplicates shows that there are 3 unique values, 1 account for each store. Due to the one-to-oneness, the lookup can go either way. We can use the store name to identify the store account, or the store account to identify the store name. Due to the way that I'm reading this data set, I would imply the store account derives from the store name, but this could go either way. Based on my interpretation, I can replace this hard value store account within my table with a VLOOKUP. Doing so has the benefit that, if this table is populated by hand, so long as the store name is spelled right, you have less chance of there being a data error in the store account field, as now, the store account does not need to be entered by hand as well. One-to-one relationships are pretty simple, so let's move on to the one-to-many relationship. One-to-many relationships are a bit more complicated. Using our left table, right table analogy, a one-to-many relationship means that there is one entry in the left table that has many corresponding entries in the right table. In this example, we have two one-to-many relationships. Fruits have a one-to-many relationship with stores. One fruit, such as apple, can be in multiple stores, Kroger and Walmart. Additionally, fruits have a one-to-many relationship with prices. One fruit, again apple, can have different prices, $1.50 and $4.50. Because of this, a lookup becomes a one-directional process. You can use the price to identify the fruit, but you cannot use the fruit to identify the price. Since the input piece is actually the fruit name, a VLOOKUP or index match does not help us here. Instead, we'll have to define the data and define a relationship by which to manage it. Now, just like we took out our store and account names, let's take out the fruit and store names and remove duplicates. Notably, no duplicates were found because each combination is already unique. So let's separate this into two-dimensional tables. A dimensional table contains definitions that describe data. One-dimensional table will contain only fruits. So I'll copy the fruit names, remove those duplicates, and see that I have 4 unique fruits. This creates our first dimensional table. I'll do the same for store name to see that I have 3 unique values. This is my second dimensional table. For each of these tables, I'm going to add a primary key that I'll call ID. This key simply assigns a unique number to each value in the table. So I'll start with 1, and I'll use a formula to populate the rest. Now, each of these has a one-to-many relationship with the other, which creates a many-to-many relationship. A fruit can have many stores, and a store can have many fruits. So how can we handle those? Many-to-many relationships can be spectacularly hard beasts to control, as it means that there are multiple values in the left table that correspond to multiple values in the right table. In order to manage a many-to-many relationship, you must have an intermediary table that tells them how to interact with one another. For us, that table already exists because we're creating this backwards. Notice that we have 3 stores and 4 fruits. That would indicate a total combination of 12 if all stores had all fruits. But our original data table only contains 9 entries, because each store only offers 3 fruits. Our many-to-many lookup table, where we've identified the fruit and the store name, defines this relationship for us. Now, for any computerized data set, data stored as a number will take up less space and require less computation for comparison than data stored as text. So we would reconstruct this lookup table by replacing the store names with their primary keys and the fruit names with their primary keys. So for example, I would replace Kroger with 1, Walmart with 2, and Tom Thumb with 3. Similarly, I would replace each fruit with the ID that corresponds to that fruit. So apple would be 1, banana would be 2, grapes would be 3, and cherries would be 4. Doing so for all of our tables generates a very basic database structure to work with. But why is any of this important? With this dataset, we haven't saved any space, and we've really only made things more complicated. So let's go back to our invoice example. We initially constructed this invoice using Excel formulas and some tricks. Excel formulas have certain strengths compared to a database-oriented solution. For one, there are more people familiar with Excel formulas than with database handling. Secondly, formulas follow the workbook's calculation rules, so they're always up to date. Whereas in comparison, if we use the data model, the formulas are hidden within relationships and the power pivot magic, while also requiring a refresh that is separate from the calculation process. The formulaic approach does have some downsides, though. Our formulas face some fairly strict limitations. In this workbook, we've only defined 12 lines. This is fine for our data set now, but it is a hard limit that would require inserting rows and copying and pasting and making sure that everything still remained linked correctly, which isn't an insignificant task for larger workbooks. Additionally, we've used both indirect and offset functions in order to create the functionality that we desire. This has added calculation overhead that will generate slower response times as the workbook grows. The Excel data model handles these relationships in such a way that the VLOOKUP is done by a pivot table rather than through formulas. As a result, we can create a version that uses data table objects, the pivot table object, and the Excel data model to get all of our fields to function like dynamic named ranges, while automatically inserting and removing rows as necessary to fit our data set without including that added calculation overhead. To do this, I'm going to have to teach you about how to use the data table object, the relationships manager, and the pivot table object. This is going to be a fairly laborious process, as I will be introducing you to quite a few different tools and quite a few different concepts along the way. Before the next lesson, take the concepts that we covered here with our fruit example and attempt to define the relationships between the tables within this invoice workbook. I've updated them to use primary keys, so try to grasp how they are related to one another and why that value makes sense. In the next lesson, we'll start with the data table object and begin updating this invoice workbook directly.